All right, for part two, here teacher Jerry here on the bonding, we talk about the macromolecule. All right, with this we understand that actually whether it has a high low melting point boiling point, it's not because of the bonding, it's more of how they looks like. So covalent also have high melting point boiling point. Like the most common one is your diamond. We talk about diamond, the giant tetrahedral structure. All right, basically macro means it's a large molecule, right, made up of a lot of atoms covalently bonded together. So we will never be able to present the whole structure of the molecule. We can only part of it because it's too big. Right. So similarly, you can see certain pattern, all right, high, then giant molecule, right, giant structure, but in this case called we use word molecule. Molecule only normally used for covalent. Then we talk about the covalent bond, you see, the large energy, to break the strong covalent bond. Right. So normally you realize that when you talk metallic, ionic, or covalent, okay, if it's a giant structure, we're talking about a bond within breaking the bond, overcoming the bond. Right? It's just that if we regard everybody as one big family, then we talk about the bond within the family members. That we don't really talk about intermolecular. Okay, most of them don't have, except later you see for graphites. But even for graphite, it is when it comes to melting boiling, it is overcoming the strong covalent bond. Okay, cannot conduct. Yeah, generally this is still quite similar to the simple molecular, right? Because all the valence electrons are involved in bonding. There's no free mobile electrons, right? And of course, sometimes we know a diamond is a harder, stronger, so you can see that it's quite similar to the high melting point, boiling point. Okay, that's that. Now we talk about force lah instead of energy, right? So technically, we need to be aware most of the covalent are actually simple molecule, low melting point, boiling point, with the exception of the group 14, like diamond and maybe silicon dioxide. You will see that it's quite similar to the diamond structure. Okay, so silicon dioxide, quite similar structure. Just that now you got silicon oxygen. Okay, diamond also have another, I mean, carbon also have another structure called graphite. All right, so we talk about layers of hexagonal ring. So you can see if the hexagonal ring means this carbon is only bonded to three carbon, one, two, three. Right? So every carbon, if you can choose to look at every carbon, it's only bonded to three. That's why you see only three out of the four is involved in bonding. So there is one, there's three to move. That's why graphite can conduct electricity in solid state. So apart from metal, graphite is another one that can conduct electricity in solid state in our syllabus. But the melting point, boiling point is the same as in diamond, same thing. All right. High, see the relationship, giant, large amount, bond, strong bond. Okay, graphite a bit special because of the intermolecular. Okay, but this one's not between the molecule. It's still considered one big giant molecule. We say between the layers. That's why they can slide. That's why your pencil lab. And that's also why when we shape answers for our OAS, we have to use graphite so that the computer can pick up the electrical signal. They can conduct electricity. And we will say that diamond and graphite, right, are actually allotropes. Allotropes means they are the same element but different structure, giving rise to different physical properties. All right, so that will be for the macromolecule. Hope that this helps you to have a better understanding. All right, thank you very much. Catch you in the next chapter.